Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have links to places where you can find information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam IFM. The material used to be an exam FM, but it's been moved in 2017 to exam IFM. Well, then MFE, now IFM. It's an old Casualty Actuarial Society problem. And here it is. You are given the following. Stock price is $50. The risk-free interest rate is a constant annual 8% compounded semi-annually. The price of a 6-month European call option with an exercise price of $48 is $5. The price of a 6-month European put option with an exercise price of $48 is $3. Assume no transaction costs, no margin requirements, and that the stock pays no dividend. If there's an arbitrage opportunity, calculate the payoff upon expiration of the options considered to an investor who utilizes such an opportunity for only one share of the stock, as well as a call or a put on only one share of the stock. Assume that the investor can invest and borrow at the risk-free rate given and uses that for any free cash flows. And here's the solution. So the put-call parity relationship says that call plus present value of exercise price is equal to stock plus put, or call minus put is equal to stock minus present value of exercise price. You need to memorize this for the test, no doubt about it. Using the values from the problem, we get the following left-hand side of that formula: $5 plus present value of $48 discounted over half a year, and that's approximately $51.12. The right-hand side of the put-call parity formula equals 50 plus 3, so $53. And the two are not equal, even though they must be in the absence of arbitrage. So there is an arbitrage opportunity, and to take advantage of it, what do? We always do the same thing. We buy the cheap one and sell the expensive one. So one must be long the cheap assets and short the expensive ones. Long call plus present value of exercise price, and short S plus put. If the investor buys the call for $5 and invests the present value of $48 in the risk-free bond, this will result in a cash flow outlay of $51.12. By shorting the stock, the investor obtains $50, and by writing a put, the investor obtains $3 for a total cash inflow of $53. There is a net free cash flow of $1.88. The difference between 53 and 51.12, which in 6 months will accumulate to approximately $1.96. At options expiration, the investor gets 48 from the bond purchased and uses that and the call held to purchase a share of the stock to cover the short if the price of a share is above $48. In this case, the put expires worthless and is irrelevant. If the price of a share is below $48, the call expires worthless and is irrelevant, but the investor must use the $48 bond proceeds to buy a share for $48 from the party long put, because the investor is short put. So short put means you have an obligation to buy if the put is exercised, and then can use that share to cover the short. And net cash flow is $1.96, which is answer B. Please remember this is copyrighted material. The problem itself comes from the Casualty Actuarial Society. The solution is mine. Good luck in your studies and good luck on the test.